Hello, dear students. This is your instructor Muhammad Ali Musawir from UET Lahore New Campus, and today's topic is Fourier Transform and filtration. So let's begin this by understanding the Fourier Transform. So for examples, I have taken here three waves. First one is sinusoidal wave, then we have triangular wave, and then we have a square wave. So Fourier transform is a thing that show us the frequency of a signal. If this is the signal in time domain, then its Fourier transform means the signal in frequency. It will look like this one. A sinusoidal wave, we know that if we have a sinusoidal wave, a single sinusoidal wave, then it will contain only one frequency, and you can see the frequency here. Okay, so you can see that we have a single pulse of frequency that is showing us that we have a single frequency. So in short, a sinusoidal wave, a pure sinusoidal wave is actually nothing but a single frequency. If we talk about the triangular wave, you can see that this is a triangular wave in time domain. So a triangular wave, a triangular signal consists of the peak signal, you can say the main pulse, the main frequency, and its harmonics. Means unlike the sinusoidal wave, which consists of only one frequency, a triangular wave is actually a sum. You can say a triangular wave is a sum of a frequency and its harmonics. Okay, harmonics means uh, the multiple of a frequency. Okay, so a triangular wave is not just a single frequency, it is actually a sum of frequency and its harmonics. Similarly, a square wave is also the sum of frequency and its harmonic. You can see that in a triangular wave we have, you can say, less harmonics with less amplitude, but in square wave we have more harmonics with more amplitude. All right, so by using frequency, you can say, by using the transform, Fourier transform, we can analyze the frequencies in a signal. And let's say that if we add a low pass filter on each of the signal, then what will happen? Let's take the sinusoidal wave first. So before adding a low pass filter in time domain, our sinusoidal wave was like this, and in frequency domain it consists of a single frequency and it will show like this. After passing it through a low pass filter, the sinusoidal wave will look like this. Means it has no effect after passing from a low pass filter. You can say just a little bit of its amplitude will decrease and nothing else will happen here. So a sinusoidal wave will have no effect by passing through a low pass filter. It will look like the same. This was the original, this was after filtration. You can see that these are the same. Similarly, if we talk about the frequency domain, before filtration its frequency domain was like this one, and after filtration its frequency domain got no changes in it. It has again the same and a single impulse of frequency. Alright, if we talk about the triangular wave, before filtration it looks like this one. And as I have said that it is a sum of frequency and its harmonics in frequency domain. After filtration, the edges will not remain just the edges. You can say that the whole wave is shifting towards the sinusoidal wave. You can see that there are no edges in a sinusoidal wave. These are curves from edges. And after filtration, the triangular wave will start looking like a sinusoidal wave. Okay, and if we analyze its frequency domain, you can see that these are the harmonics, and the harmonics are very much reduced here. We got only a single harmonic here. Okay, so I can say that after passing through a low pass filter, its harmonic will decrease, and you can see the effect here. Alright, if we talk about the square wave, before filtration the square wave was like this one, and it has a great harmonics. After passing this signal through a low pass filter, it will look like this one, and again the harmonics will reduce. You can see that here we have a great number of harmonics, but here is amplitude also, the number of harmonics is decreased here. And in this you can say the time domain, it will look like this one. All right, okay, so this was the theoretical concept of Fourier transform and its filtration, the signal filtration. Let's move towards some practical so that we can see what actually happens to a signal. Alright, so this is our sinusoidal wave before filtration. You can see here clearly that this is a sinusoidal wave, and now this is our filtered output. You can see that there is no difference in before filtration and after filtration part. You can see both are exactly the same. Okay, now this is our filtered triangular wave. You can see that the triangular wave is shifted towards the sinusoidal wave. Okay, perfect. Now let me show you the square wave. This is the square wave before filtration. You can clearly see that this is a square wave. Okay, and now let me show you the filtered output. This is the filtered output of a square wave, means after passing a square wave from a low pass band filter, the output will look like this. All right, now hope so students you got all the things. Thank you for watching.